Okay, good afternoon. Your attention, please. Good afternoon. Okay, so we are starting our next topic in this course, Module 2, Algebraic Equation Solving. It's basically a discussion or a list of techniques that I can share with you that will help you solve equations that you can't solve with your regular bag of tricks. Like, you know how to solve equations, right? If I write ax plus b equal to 0, it's a linear equation. You know what to do with this. If I write quadratic equations, ax squared plus bx plus c equal to 0, you know how to do this, at least most of you do, as I saw in the prerequisite quiz. Um, what do you do with equations that don't fit your regular paradigms for polynomial equations? That's essentially what we are going to learn today, or not in today and next class. So if you think about these type of polynomial equations, so if I write ax power n plus bx power n minus 1 plus and so on equal to 0 until the last term, which could be like, let's say, f equal to 0, you can count how many solutions exist for each of these. But when you have certain equations, you sometimes you can't a priori predict how many solutions to expect, and not all the solutions will be relevant to you. When I show you a solution to this, you'll see this x that appears in the equation often models a physical quantity that you're trying to solve for. And this problem or this equation, if it has a number or solution which is negative, maybe that physical quantity cannot be negative or it won't make sense. So there are some physical constraints that impose the limits on the solution. And you have to think of this as the numerical procedure will tell you what all values can satisfy this equation, but we still have to apply our logic and physics constraints to understand which are possible solutions to the physical problem. So there are two things here. One is the math equation which can look like this. The solutions to this must be filtered based on physical constraints and engineering considerations. So that's just a one line about the philosophy behind this. But let's get started with this equation here. If I give this to you and just say solve this and provide me an estimate of what value of x will satisfy this equation, what will you do about it? Not knowing anything else that comes later. At this point, what are your instincts? Okay, bad answer. Sorry. And if that's the point, we don't need this course. We can all go home now. Like, how do you start? Where do you start? So what Sophia is saying is, guess a value for x. Guess a value for x. Compute the left side. Compute the right side. And check the difference. And until this difference gets to 0 or difference becomes small, continue iterating. That's in a nutshell. It's okay. This is an approach. Thank you. That's actually a valid approach, but it would be a brute force approach because there is no, you're not applying any particular consideration to what is a good guess value or what is a bad guess value. If you make a bad guess, you just have to iterate longer. And in the world of computing, you want to minimize the computing operations that you do or the number of iterations you do. So we are going to take this brute force approach and try to make this a little more refined so that we can do this more efficient. That's the whole point of this module. Okay. Any other thoughts about how you will solve such an equation? If I just give it to you, if it's in some other course.
Yeah. You say no calculator, but that would imply no graphing as well.
No, that doesn't imply that.
So then you do graphing.
Exactly. Calculating by calculator, that if you just use a built-in number, it just spits out a number that doesn't teach you anything, but a graph teaches you a lot of things. That's what I. You didn't say that. You didn't say that. Yeah. Okay. So if we take this left-hand side function, that's e power minus x. So if I plot this from x equal to 0, it starts at 1 and it just decays quickly. This is e power minus x. Okay. And how would cos 4x look like? What is cos of 4 times 0? Cos 0 is 1, right? So at x equal to 0, this should also have the same value, right? And it should go something like this, right? So the specifics will vary because if I said instead of cos 4x, let's say I said cos x over 2, the shape of this cosine curve will vary. But at the end of the day, it's going to go up and down, and it could possibly intersect this curve at more than one point. So the most obvious, intuitive, easiest approach, in fact, when you set it up for visualizing the problem, we call that the graphical method. Okay, graphical method, where the first step is to graph either both LHS and RHS, or you can say graph the equation, let's say f of x equal to 0, and then you check for whether if you want the points of intersection or if you want the point where this function crosses 0. So if you plot, let's say, e power x minus cos 4x equal to 0, which I call f of x equal to 0. So I'll plot f of x versus x and see where this function crosses 0 or something. These are all possible routes or solutions. This is a method best done with the Excel sheet or MATLAB or a software. So we will use this for visualization. And then there are 3 more techniques which are more paper-based and algorithmic, which we will learn for testing in the exam. Okay. So first thing is I'm going to show you the graph of this function, and we are going to identify the roots of this equation. So I have an Excel sheet here. I have posted this on Canvas. If you are on Canvas now, you can actually find it. All right, so this is our equation, or actually this is, I've been making this spreadsheet. So I have this all done here, but we'll start over and do this from scratch. Okay, so for a minute, please listen. No need to write. You're just going to look at my spreadsheet and then we'll come back and do the problem. So I took a range which is roughly 0 to 8 pi. 8 pi is 25.13, but if you look here, this is 8 times pi. So I did the graphing between 0 to 8 pi so that I'll at least cover 2 periods of that cosine function, cosine 4x. Okay. And I divided that interval into 100 steps. which means each step must be 0.25 approximately. Does this make sense? I'm graphing a range, so I have to pick a resolution for my stepping. So I did 0 to 8 pi in steps of 0.25. With me? Yeah? Good. So then the next step is I just have a value of x, and then I keep going in steps of the resolution. So if the first point is x minimum, which is 0, please, I request some of you to look up and focus, not do the work now while I'm talking and while I'm explaining. It'll then, you will be lost then, and then it'll just propagate. Okay, so please listen now. So you start with the first value, add the step length to each value. So first step is 0.25, 0.50, 0.75, 1.00, and go on. And this goes until the end of the interval, which is 25. Okay, just creating an interval where I'm doing the graphing, nothing more than that. Okay, and then for each of that, I compute the value of the left side, which is exponent of minus x, and the value of the right side, which is cosine of 4 times x. You'll get a chance to do this on your own, so please don't worry about doing it right now. Okay, so do calculate the LHS, calculate the right side, and then you say I'll take the difference between the left side and right side, and that is just the difference between column H and column I. Okay, so we have that, and then as you know in Excel, you can extend this calculation all the way down to the last row. So you get 100 data points which run from 0 to 8 pi, and you can compute what's the left side, right side, and difference. Okay, then I did a graph where, I hope this is clear. This blue line, okay, I must tell you something about myself. I think I'm colorblind. I'm very terrible with colors. So I use my mouse pointer only because I can't tell whether it's green or orange. Okay, so bear with me. So this line here that I'm pointing to, can you identify which function it is? That's the exponential. It decays quickly. And the other is the cosine function, which oscillates up and down. Okay, so graphical method is nothing but a fancy way to say identify where the points intersect or where the curves intersect. There I can at least spot 4 of them or maybe even 5 of them. And what is the defining characteristic of a point of intersection? If two curves cross at a given point, what does that mean? Theoretically, the difference must be 0, but within the resolution with which you did your stepping or the calculation, it must be a small number. Like the difference should go to a small number. Okay, so let's check between just after 1. Okay, just after 1 and somewhere before 1.5, there must be a point of intersection. You all agree? Yeah. So let's go back to the table, and we are going to do a search for between around 1 to 2. I'm going to highlight this. I'm going to check for a point where my difference is the least. Which would that be? Which entry would that be? Number 6 at x equals 1.25 or 1.26. So the difference is minus 0.02. Before and after, the difference only increases in magnitude. Don't worry about the sign. It has to be the closest, which means the absolute value has to be very small. With me? Sorry?
And number 12 on this.
Number 12?
Difference.
So I'm asking between 1 and 2. I said I want to look for the root that comes between 1 and 2. This is probably another solution. There are multiple solutions. So between 1 and 2, 1.25 seems to be the value at which the difference is least. Good. Everybody agrees with me. So then the question is 1.25 the solution to this equation? One 1.25 is the solution. I mean, you can see it both ways. 1.25 may be considered to the solution of this equation if you are happy with the 0.25 resolution. If you want to step in terms of 0.25 as your step length, you can get to within a 0.25. You can't get any closer. You can't say whether it is between. You can't say whether it's 1.30 or 1.35. You can say it's 1.25. The next stop is only 1.50. Got it? So then if I want to improve the accuracy of my answer or the resolution of my answer, what should I do? Increase step count or decrease the step length, right? Instead of doing 100 points, I could do 200 points, which would at least double my resolution or half my step length. Or I can do 1,000 points, which will get the answer within 0.025. So the trick is simple, make the graph finer and you can go as fine as a resolution in your final answer. Okay, yes.
Why don't you use goal seek to find the?
Find what?
You can use goal seek and compare the value to find it.
I don't understand. Find, use what?
Goal seek.
Goal seek? Yeah, you can automate this. So I'm just trying to introduce the concept first, then we can talk about automation. Okay, so this is between 1 and 2. All right. Now, if you go back to the graph, there is another point of intersection between or closer to 2. Okay, it's somewhere between 1.5 and 2. So if we go back here and you look for that, between 1.5 and 2, there seems to be another minimum. Sorry. At 1.5 and 2. Yeah, we just saw this. And this is between, this is 2.01. Okay. So if I look here, if I consider these 3 points or these 4 points, the difference is 0.55, that is the absolute value. It decreases and then increases. So 2.01 is also a potential root, except its resolution is pretty poor. So we have to improve that. So this graphical method is kind of a very intuitive method. You can plot it, you can visualize it, you can understand what are the ranges in which we can expect the roots. But this method itself is quite tedious because you have to graph it and you have to to get final resolution. It's not easy. The other point is automating this is more cumbersome than automating few of the other techniques that we are going to see. So in our purposes, at least in the classroom, we will use the graphical method as a way to generate initial guesses, like what Sophia said before. Guess a value, compute the left side, right side, check for the difference and iterate, right? I said it's brute force. Now we can make it a little bit of a finer method by taking the initial guess coming from the graphical method. So it gets you within striking distance of the answer. Then we use the other techniques that we are going to solve. Okay. So in the exam, this won't appear. In the exam, you will either be given some initial guesses and asked to use that. But in practice, in daily life also, or your professional calculations or work, you will use the graphical method more often than anything. That's why I'm making a point to introduce it. Okay. Questions? No. Okay. Yes. Which two columns? What is on F and G? So I was essentially playing around with how to generate the 2 columns of X. what I did was first take the first row, add the resolution, and then keep going. The other is to use the counter and generate it. So it's just two ways of generating the x values. Okay. Okay. So let's take the same equation, and we are going to use this chart and say there is going to be a guess value, or there is going to be a value of the root between 1 and 1.5. Okay. So we are just going to take that piece of information and learn another numerical method, which is equally intuitive. You have played Angry Birds game, right? All of you. When you play the game, can you describe how your mind generates the next value for the angle of the bird, as well as how much force or how much initial velocity you should give to the bird? Or forget even Angry Bird, that is a digital version of the game. But if you play sports, like you play baseball or football or shot put or any event, how do you think your brain works in generating how to plan your next trial?
It's an adjustment based on. So you throw it too high, you're gonna try to throw it low the next time. So every time you're dancing around what you're trying to achieve.
So you are iterating, right? Our brain literally is iterating. It takes one piece of information, which is the previous time whatever angle or force that you gave, and it takes one more piece of information. What is that information? Where the ball landed. That feedback is so crucial, because that feedback tells you whether you overshot or undershot, and then your brain adjusts what should you do in the next iteration. The best athletes, the elite athletes, essentially have done this many more times than everybody else. That this feedback process is so internalized in them, they can do this better than most people. That's what makes them elite, right? So becoming an elite athlete essentially is a matter of practice and letting your brain learn the feedback enough number of times, so you could do this repeatedly time after time to win contests, essentially. All right, so now you have that logic. We are going to solve this equation, okay? And we are going to use a technique which is kind of like that process of playing Angry Birds. So I'm going to write a couple of things here. This is our equation. So we make a guess. Actually, we are going to make two guesses. I'll tell you why. Compute the consequence of that guess. In other words, in your brain, you decide at what angle you want to throw and how much force to push through, and that lands somewhere. And then we compute the consequence, calculate the feedback, which is the difference between the consequence minus the guess value. And we are going to iterate this until we are satisfied, which is another way of saying until the answer or the solution is of acceptable accuracy. You want to write this down. It's not mathematical, but at least it tells you what the process is, and then we'll turn it into a math statement. Okay, so recall from the graph, there is a root there is a root between x equal to 1 and x equal to 1.5, meaning that is e power minus x minus cos 4x equal to 0 is satisfied for at least one value of x in the interval 1 to 1.5. Okay, just translating it. Okay, so if I take f of x equal to e power minus x minus cos 4x and I plot that versus x. Okay, when I say this function has a root in this interval between 1 and 1.5, what does the root literally mean? It means this function has to cross 0. Either this function has to go like this or it has to go like this. It has to cross 0 somewhere, which is what we are trying to locate. Okay, so we saw the graph, so we know it's between here. Okay, so if this is the case, how can you turn that into a math statement or a condition that a root lies between two values? Let's say we have two values a and b. If I say a root lies between a and b, what must be true? It crosses 0, which means the two values, if I call this f of 1 and this is f of 1.5, or this is f of a, this is f of a, and this is f of b, or the other way, this is f of a and this is f of b. What can I say about f of a and f of b if a root lies between them? This function crosses 0. Okay, meaning it changes sign. It either goes from positive to negative or negative to positive. If that is the case, what can I do about f of a and f of b? They are on opposite sides of this line, either way, right? If I take the product f of a times f of b, would that be negative or positive? That would be negative, right? Why? Because one of them is negative, the other is positive, which is the only time when the root can lie between them, right? So the condition is f of a times f of b is negative. If a root lies between them, their product is negative. Or the other way, if their product is negative, then a root lies between them. Would you agree? At this point, you don't need the compute, you just have to write. This is a critical statement. If a root lies between them, their product is negative. If a root lies between a and b, then f of a times f of b is negative. Do you agree or not? If you don't agree, let's discuss. Good. That makes sense. Yeah. Thank you. So it goes both ways. If f of a times f of b is negative, this implies a root lies between A and B, or if a root lies between A and B, that implies f of A times f of B is negative. Yeah,
Is it the same as intermediate value theorem?
kind of. Kind of, yeah, they are all related. It's like intermediate value theorem is like average. This is also literally average because we are going to iterate by taking the average of A and B. Yeah.
What happens if a phase starts as positive, touches the x enters the x horizon, and then it goes back up?
Like you're asking like this, something like this. Okay, so this would be a point of maximum, which would still. So this is actually a special case. You are saying at this point not only the slope zero, the function is also zero. So we'll deal with it separately. Okay. Right now, I just want to deal with the most common case, which is if the root is contained between two values, let's say A and B, then this must be true. The corollary is also true. If f of A times f of B is positive, this implies there is no root, there is no root between A and B. So this idea is what we are going to use in all the techniques we'll see. This is essentially boxing an interval where the root exists, and this comes from graphical method. So graphical method is often like helping us identify the guess or narrow down a range where the root may be found. Okay. And again, only during class, meaning for exam, guess will be provided. Okay, yes.
Isn't it positive when you have two roots between A and B?
If you have two roots, that's like the graph does something like this. Like this is a root, this is a root. I'm only considering A being like this. I just want to consider between. I just want to consider an interval which contains only one root. If you want to consider the second root, you would consider between B and C, which contains one root, or a third root, which is contained between C and D. Okay. So let's come back to this problem. Let's try to solve this. Okay, where we found from the graph there is a root between x equal to 1 and x equal to 1.5. Okay, with me? Yeah. So this picture is important. If you don't have it already, please sketch it in your notebook. I'm going to erase it. Okay. All right, we'll say the value of A or x equal to A and the value of the function at x equal to A, x equal to B, and the value of the function at x equal to B. So in our first guess, x equal to 1 and B equal to 1.5. A equal to 1, B equal to 1.5. Can you please compute what is f of 1 and what is f of 1.5? Because this is literally what you're going to do in the exam. Let's do this by as a hand calculation. This is like e power minus 1 minus cos of 4. Remember, this 4 is in radians, not angle. This is in radians. And this is e power minus 1.5 minus cos of 6. Can you compute this and tell me, please? This is, I'm getting 1.021 and this is negative 0.737. Can you confirm, please? Okay, good. Okay, good. So first thing you got to check is f of A times f of B. You don't need the product. You just need to check whether that product is negative or positive. So instantly you can say this is negative. Which means even if you don't graph the full function, here is 1, here is 1.5, and f of 1 is positive, and f of 1.5 is negative. So this is where your root lies. Okay. All right. So now we have kind of identified it's between 1 and 1.5. That's like almost saying you are solving it down to 0.5 resolution. How do you get it, make it better? Think about your shot put or your Angry Bird skills. How do you make the next guess better? Why 1.25?
We're gonna check if it's positive or negative.
I asked why 1.25.
Oh.
You did right. You're very intuitive. You think like your brain. But why? Just try to explain.
Somewhere in between.
Somewhere in between. And average seems to be a convenient choice, right? So we'll say we'll take the average of the two, which would get us the value 1.25. Okay. So we'll say C, the third value, equal to A plus B divided by 2, and that is equal to 1.25. Yeah, good. So now you have to think in my sketch, should I draw 1.25? Should I draw the curve to the left of 1.25 or to the right of 1.25? Meaning, is the root lying between this lower limit and the midpoint, or is it between the midpoint and the upper limit? That's the question. I don't know. I just drew it approximately. So how do you check that? Louder, please. Everybody has to hear that. So you're saying take the same condition, now apply it between 1 and 1.25 as well as 1.25 and 1.5 to see whether which is negative. Whichever interval gives you a negative product contains the root, right? So the next step would be to compute what is f of c, that is f of 1.25. What is f of 1.25? Can you compute and tell me, please? Minus cos phi. Sorry, what was that?
0.02.
0.028. Okay. Negative 0.028. Okay. With me so far? You got a positive number?
And 2 zeros.
We need a tiebreaker, please.
0.002.
0.0028. Okay. Okay, I'm just going to use Excel sheet to tell me 0.0028 positive. 0.0028. Yeah. Okay. So what do we do next? Can you tell?
Before it goes into.
So you're saying if I multiply these two, this is A, this is C, f of A times f of C is positive. Listen, please, you can take a pause from writing, please listen. If you take the f of A and f of C, that's positive. What does that imply? It doesn't exist between A and C. Okay, it is not between A and C, so my picture is wrong. If you notice, the picture has to be drawn with the curve passing between 1.25 and 1.5. Okay. If I take this value, this is B, f of B times f of C is negative, which means x lies between 1.25 and 1.5. I'll give you time to write. Please focus. Okay. Yeah. Now that was easy. You just looked at three values. You manually did the product. You looked at the numbers and said this is positive, this is negative. So the root lies between 1.25 and 1.5. Now, how do we automate it? How do we turn this into a statement which can just be done repeatedly without our intervention? I want you to tell me a statement or a condition to check at each iteration that is self-propagating, and we don't have to do this manually. Yeah. Louder, louder.
Oh, so we do the same thing for the energy ranges, and then same thing, but in terms of side is
The product is negative. Right.
and where we can find the left side, the low end range or the high end range using change, doing that to get closer and closer to what I said would be resolution.
I agree with the last part. So if I just want to make some changes to what you said, mostly you're right. So I got this C, right? Okay. Now, how will I do one more iteration of this process? What's the next iteration going to look like? That is, I know I started with 1 and 1.5. I have now calculated a midpoint, and I have now narrowed the range between 1.25 and 1.5. So this part of the domain is not relevant anymore. Do you first agree with that? You don't have to now carry around the 1 to 1.25 because that surely doesn't contain the root. With me? So the next iteration has to occur between 1.25 and 1.5. Would you agree? You have narrowed, the whole point is zeroing in, spawning in, okay? So let's do the second iteration. Let's do the second iteration. I'm going to erase part of this to make space. Are we okay? Can I erase one line? I don't need f of 1. Okay, so I'm going to write the old C value is going to be my new A value, and B value just carries over. C is the new A, and B carries on. Reason I write these textual statements is when you go home and look at this, it may not make sense. So hopefully these annotations will help you. Right? So what is f of A? This 0.0028. F of B is minus 0.737, which makes f of A times f of B again negative. So C value would be 1.25 plus 1.5 divided by 2 equal to 1.75. So you've now boxed it even closer. Only question is to ask whether it is between 1.75, I'm sorry, 1.25 and 1.75, or between 1.75 and 1.5. Yeah.
Would it be 1.75?
Oh, sorry. Today I should not have too much coffee. Thank you. 1.375. Okay. So then how do you check that? You compute what is f of 1.375. Can somebody tell me? negative 0.455, I'll take that. Negative 0.455. Okay. So if this is negative, f of 1.5 is also negative. F of 1.25 is positive, which means the root is now between these two values, between 1.25 and 1.375, and this part is no longer relevant. We don't have to search there. We know it's not there. Essentially, root finding is just searching. Okay. So you can repeat this. You now look for you now write the third line of this iteration, where this is 1.3. Sorry, this is, so here A carries on, while as C is the new B. So this is 1.375. Sorry, this is 1.25 and this is 1.375. So you have now come. So what's the width here? This width is 0.5. This width is 0.25. This width is 0.125. So you are closing the gap. So closing the gap. What do you do next? Same thing. So what is the midpoint? The midpoint is 1.3125. Thank you. 1.3125. And I have to compute what is f of 1.3125. I just need to know if it's negative or positive. It doesn't have to even know the number. Negative? Okay. So f of 1.3125 is negative. So what does that tell us? So this number is negative. This number is positive. Sorry, this number is negative. This number is negative. That is 1.3125 and 1.375. They are both negative, which means what? If the product of this function, the function at 1.3125 and the function at 1.375, if the product is positive, what does that tell you? It's not in this interval. You're continuing to box it. So you get the pattern how this goes. Now you have to tell me how you will automate this. It's easy. You're now getting the logic. You have to now make it into a self-standing algorithm that just can be done on Excel or MATLAB. Can we try? How will you automate it? Or like, what statement should you put, like a if condition that you check that and decide how the next iteration should proceed?
So it would be like if the value popped out is less than 0,
Okay.
then you would go back and continue the loop. But if it's greater than 0, then you have to
I mean, you're not off track. What you need to think is, how can I write it in a way that I don't have to say anything more than that one statement of condition to check. So how do you start the process? Think of it. Let's go step by step. Okay. What is the first step? Choose an interval x lying from A to B such that f of A times f of B is negative. That's how you pick your guess value. Suppose in the exam, I just tell you solve this using bisection method, but I didn't give you a guess value and you started by violating this condition. You can't get any more points there because everything else you do later is going to be wrong. Okay, so this is the first step where you have to start such that the root lies between A and B. Okay, that's the first step. All right. Second step will be compute the midpoint C equal to A plus B over 2 and also compute f of C. Yeah,
Like what you did on the Excel sheet? You
yes.
found the point, like you found a range.
I found a range and that range is guiding me what A and B must be. If you do it in practice or real life, you would do that yourself. In exam, either I'll provide A and B or I'll ask you to make some reasonable guesses with your own intuition.
So
I'm going to provide A and B, the range in which the root is to be searched. I'm going to give you that as a starting point. Yeah. Okay. Okay, we computed midpoint. You can do it like this. Take f of A times f of C, or check the product of A and C. You don't have to think too much here. Let's say your interval is A to B and C is your midpoint. Just check f of A and f of C. Don't worry about should I check f of B. Don't worry. This is an algorithm. It will work. Check the product. Okay. If f of A times f of C is less than 0, what does that mean? The root lies between A and C. Okay. Then for the next iteration, the root lies between A and C, which means A remains as A and C becomes the new B. Yeah. If it goes through like this, you just have to call this the new B. Yeah. Okay. So then let's continue here. Okay, so if it's negative, this is the case. What if this is positive? That is, else what happens? It can either be negative or positive. So if it is not negative, what will happen? If suppose, so this is one case. Okay, I'll call this case 1. And what if this is the case? This is case 2. In that case, what happens? C becomes the new A. So A new becomes C and B new is just B. That's it. That's your algorithm. Okay. And you iterate until when? Until it's lunchtime. Until the difference between the two values is very small or to your satisfaction. Until A minus B, the difference is within a certain tolerance. So we'll say epsilon is a chosen tolerance. Suppose I tell you solve this equation and get me an answer within 0.001. So epsilon will be 0.001. You will iterate until that condition is met. Obviously, you would have guessed it. This method is called bisection method because you bisect the interval. I mean, you have to choose A and B, either graphical method, or if you give me a function that I really don't know, let's say, for example, you give me e power minus x squared minus 4x cubed equal to 0. I can't tell really what this is. But what I'll do is I'll try to take some simple values. Like let's say I take x equal to 0. This implies the function. What is the value of the function? 1. Okay. Let's say I take x equal to 1. F of 1 would be e power minus 1 minus 4. Now I don't have a math degree, but I know this is negative, right? So I'll just say there is a root between 0 to 1, good enough to get started. Now then we'll fine tune and get to a resolution. Okay, so most often if I don't give a guess value, you are supposed to do something like this, not like always 0 and 1, but pick appropriate values and try to identify an interval where the function changes sign. Okay. Shall we do an example that you will do and then I'll cross check? Yeah. Did you have a question? Yeah.
What do you mean by?
Chosen tolerance mean, let's say I ask you to get the root to this equation to within 0.001. That is, the A and B should differ no more than 1/10,000. If I tell you that, that becomes a tolerance. Or I won't be telling that all the time. Sometimes the engineering problem you're trying to solve will dictate to what resolution or accuracy you need to solve this equation. No greater than this number. Yeah, that's correct. So if they get so close that after this there is no gain in continuing the iteration, you stop. Yeah. Good question. Okay. So then let's try one more problem. Solve 1 minus x squared minus sine x equal to 0. Solve 1 minus x squared minus sine x equal to 0. Using this bisection method, of course. And in this unit, we are going to learn like 4 methods, and actually we have already learned 2 of them. Just 2 more to go. You can solve any problem with any method. So when you practice, what you should do is if you pick a problem from the book, solve it using all the 4 methods when you practice. Okay, because any of them might be asked in the exam. And speaking of which, there will be 2 problems on this unit. So you'll be tested on 2 out of 4 methods. And I'm telling you, you won't be tested on graphical methods, which means 2 out of 3 methods. Okay, let's solve this. It's easiest to check for f of 0. F of 0 is 1. What is f of pi? F of pi is 1 minus pi squared minus sine pi, which is also 0. So this is negative. So off the bat, I can make a guess that between 0 to 1, there is a root. Yeah. So let's fill out the table. So I'm going to write A, f of A, B, f of B, C, f of C, f of A times f of C. So if A is 0, B is 1, f of A times f of B, C equals A plus B over 2, and f of C and f of A times f of C. So before you start, make sure you put down all these columns. It'll really help you be organized and get it right. So f of A is f of 0 is 1, and my B value was not 1, my B value was pi, and f of B is 1 minus pi squared, which is clearly a number that's negative. So f of A times f of B, of course, is negative, which is good. Okay. And what's the average? The average is going to be 1 minus pi squared over 2. And at this point, I wouldn't keep the pi squared. I would convert this to a decimal number and move forward. So what is 1 minus pi squared over 2? Can you compute and tell me?
Negative 3.9.
Negative 3.9. So this number is negative 3. Can you tell more decimal points? Like, so here is some suggestion. Always maintain 4 decimal points in intermediate steps. Decimal points in intermediate steps. And report the final answer as specified in the problem, or exercise your judgment. I'll tell you at the end, I'll tell you how to present your answer. Exercise judgment. So can you tell me more decimal points?
0.9348.
Louder, please.
0.9348.
9348. Minus 3.9348. Okay. And what is the value of the function at minus 3.9348? What would that be? You need to use your calculation. The calculator here. It's going to be in test tube. Zero and pi squared. Sorry, pi. Okay, what was our first value? 0 and pi, right? And C is the average of the two. Okay. And what is our f of x? 1 minus x squared minus sine of 1, sorry, sine of 0. Okay, so the product of this is all right. So C is, what was C again? 1. Okay, this was wrong. C is not 1 minus pi squared over 2. Nobody told me that. Is A plus B over 2. So 1 plus pi over 2. Sorry, 0 plus pi over 2. 0 plus pi over 2, which is 3.1416 divided by 2, or 1.57. You can look at my Excel sheet. 1.5708. So maintaining 4 decimal points for consistency. 1.5708. And what is f of c? And what is the product of f of a and f of c? What is f of c? Minus 2.4674. Thank you. Minus 2.4674. So look up, please. F of c is negative. F of a is positive. So the product is also negative. This is what I hope to see in your exam solution, a table and methodically progressing through the iterations. So how should I populate the next row? So this number is negative, which is what you really have to pay attention to. You did everything right and this number is negative. It means A carries over and B is, C is the new B. C is the new B, which is 1.5708. And repeat the calculation. So this number again is 1. This number is minus 2.4674. It's a good sanity check to make sure that at every step, this column remains negative. If it suddenly turns positive, something is not right. And the midpoint is, you can calculate the midpoint. Point 7854. 0.7854. And f of c is, anyone? Correct. Negative point minus 0.3240. And f of a, f of c is negative. F of a is positive. So this continues to remain negative. I take it that folded hands means it's so simple that you're bored. Take it. Okay, so this is negative, which still means the new A value is same as the old A value or current A value. So this is new, this is current. And then this becomes new, this becomes current as you iterate. F of A is still the same. F of B, what should B now? What should B now? That's the old C, the current C. So this will be 0.7854 and then minus 0.3240. Again, a good sanity check is to check whether f of a and f of b are negative, which they are, and the average of 0 and 0.7854 is 0.3927. Can I erase this part? Yeah. This part. So what is the value of f of c? F of c is positive. Okay. So the product, if you're sure about f of c being positive, f of a is positive, f of c is positive, which makes this positive. Is everybody coming to the same conclusion? So in your exam, how do you save time? You just have to ensure that you get the sign of these functions correct. You don't need the value so much. You don't have to keep executing the function. Like you can skip some steps if you're smart. So this is positive, that's new. If both f of a and f of c are of the same sign, what's the next step? If the product of f of a and f of c is positive, what's the next step? Current c becomes the new a, right? So this value becomes 0.3927, 0.3927, whereas b remains the same as 0.7854. So this is positive, this is negative, so this must be negative. 78, which is what's the midpoint of 39 and 78? That would be 0.5891. Anyone? 0.5891. So then you have to compute what is f of 0.5891, which is 1 minus 0.5891 squared minus sine of 0.5891.
Zero point zero nine seven three.
0.0972. So, sorry?
0.0973.
Okay, so f of 0.5891 is a positive number. So this is positive. So if you now think about what is f of a times f of c, that is positive, which means in words, what does it mean? Okay, let's hear from the rest of it. If this is positive, what does that mean?
You do the same thing again, your C becomes your data.
Your C becomes the new A and B carries over. You should be able to tell this. If you look at your table and you can't spot the mistake, you can't troubleshoot in your exam. Remember this. So you should be able to tell this. So C becomes the new A. So 0.5891 and B carries over 7854. So you get the hang. Okay. Now tell me, how do you monitor this process? How do you keep checking some quantity such that you know when to stop? What should we keep checking? That will only help you go to the next iteration. The difference between FB and FA, that's one quantity to check. FA minus FB, you can keep checking and see if this approaches 0.
Distance from A.
The distance from A and B, if this approaches your chosen tolerance, then it's time to stop. Because if you keep doing, you will only get, you won't get any significant improvement. So your effort is just best if you stop here. That makes sense? So you have to keep monitoring two things. If they are both kind of equivalent, if you monitor the function and the function goes to 0, that's like saying I'm solving the root. Or if you monitor the distance between A and B, and that becomes so tiny, it's practically the same point, so you can stop. Okay, so this number in the exam could be something like 001 or 0.001 and so on. So just how do you select this criterion, or how do you present your final answer? Either the problem would say directly how many decimal points to report. If we ask for, let's say, 4 decimal points, in the intermediate steps, you maintain 5 decimal points. Then you round up at the last step. If you ask for 3, maintain 4. If you ask for 2, maintain 3. You get it? Or sometimes when there is no guidance or you're not told what to do, you can exercise your judgment. You can say, I'm going to report my final answer to 4 decimal points. You can make that decision, but it should reflect in your intermediate steps. You can decide 3 because it's easier, obviously, but you should maintain 4 in the intermediate step. Okay. So what I would suggest as homework is, you're going to do this on a sheet of paper. Solve this problem using bisection method. Okay. Also, check the answer with graphical method. And you take a picture of your solution on the paper and a screenshot of your screenshot from your computer, and upload both of them to Canvas for getting your participation score. You have to solve this problem. We'll write e power minus x squared minus 4x cubed equal to 0. This is your problem. Well, sorry, that's not your problem. This is your problem. To solve this problem, I need 2 files. The picture of your handwork and a screenshot from your computer with the graph. Okay, I'll give you time until Thursday at noon to upload this before we come for next class. I've created a Dropbox on Canvas. Just upload the 2 files, and if we see the file, we are going to give you credit. Yes. We are not done yet. There are 5 more minutes. Settle down. Yeah.
So what is F of A? What is F of A and what is F of B?
F of A and F of B are the values of the function calculated at A and B. So if A is 0, that's like substituting 0 in this function and computing what is f of 0.
So for our final answer. Is that supposed to be? Is our final answer the difference between A and B?
The final answer is if A and B are close enough, it's like, so let's say you get down to, I don't know the exact answer, but let's say your A value is 0.6001 and B value happens to be 0.6003. Just for example's sake. You can take this value and report either A or B or their average, and it would be practically the same. So the whole point of iteration is to get close enough that you can just say A, B, or A plus B by 2. Any of one of them is an appropriate choice. Okay. If you think about it, this is your point of intersection. And let's say this is either A, B, or A plus B over 2. You're trying to find where it is intersecting. Mathematically speaking, it's impossible to get the exact value because the exact value has an infinite number of decimal points. So you get close enough. Okay. All right. Good. So I have 4 minutes. I wanted to ask about, are you forming groups for your project? Are you selecting hypothesis driven projects? I haven't had any communication from any group asking is this a good project to choose or something, but are you making progress on that? That was what I wanted to ask. Have you formed groups? You can think about it. You don't have to tell me now. Have you formed a group? If not, you should. If you formed a group, good. Have you thought of what is a hypothesis that you can test? And it should be a data collection which should be non-trivial in the sense it should be something meaningful, but it shouldn't be too costly or too involved. It must be something you can actually do. Yes.
So, what we're doing, should we be having a larger sample size? Or if we've got a smaller sample size, should we run multiple trials?
It depends on what your problem is. It's very hard to answer that in the abstract. So once you bring me a project problem, we can talk about the specifics. Yeah.
Did you ask if we were allowed to do surveys?
I haven't asked, but I'm thinking it should not be a problem. But there are some standards for how to collect data and anonymity and everything. Maybe we can talk and figure out what the rules are.
So for the project, are we just looking at margin loss or like basically?
Only margin loss. Just margin loss. Okay. Okay. So for the exam, it's exactly about what, like on Thursday, March 5th. Yeah, 5th. So this whatever we discussed today will be on the test. So you should start practicing right away. So please don't, it's not in the far distant future. I would like you to do at least 10 problems from the book. I have posted some suggested problems. Just try to apply this method for 10 different equations. Okay. So please try that. Yes. This is going to be on the test. For next week, yes. Whatever I discussed today and on Thursday will be on the test. So please start preparing. I wanted to mention that. Okay. Thank you.
Okay.